When thinking about the history of science, many people come back to two figures, Galileo and Newton. Newton, of course, being famous for his laws of gravity after an apple fell on his head. Today, Brian Thornton, who's joined me here, gave a lecture on the Clockwork Universe. Now, do you think it does just boil down to Galileo and Newton, or do you think there's a bit more to it than that?
There's more to it than just these two key figures. To put it in context, what we're talking about here is moving from the sort of certainty of the Dark Ages, in which the scholastics, who were followers of Aristotle, dominated the sort of intellectual life of Europe. In order to understand the sort of seismic and cataclysmic transformation that this scientific revolution sort of brought to the European intellectual life, I think we need to understand basically where we were before this happened. and where we were was in the Dark Ages, a time that was dominated by dogma, by books, two books predominantly, the Bible and the collected works of Aristotle. And it was believed that this was all the knowledge you needed. This was all the knowledge you needed to know. And what you did was you learned this. And through learning what was written in these books, in these sacred books, you could understand everything, and you could understand the universe. And we moved from this certainty into sort of uncertainty through people such as Copernicus, Kepler, Galileo, Newton, people who embraced an empirical approach to knowledge, to sort of admitting that we didn't know certain things, but using that as a sort of as a spur to be curious, to try and work things out through experiment and so on. The key figure in this sort of scientific transformation was Copernicus, because he attacked a key precept in the Aristotelian intellectual landscape, which was that the Earth was the center of the universe, which makes sense if you believe what is written in the Bible, that we are the chosen people. We are the sort of the sacred people chosen by God. Where else would a God place these chosen people but at the center of the universe? The key figure which fitted into this model perfectly was Ptolemy, and it was the Ptolemaic scheme of the universe, which the scholastics and the people, the key figures at this time, who they thought he had got it right, that everything, including the sun, revolved around the Earth. Copernicus, he went head to head against this and said that this is not actually the case, that the Earth was just another planet, planets that are observable, and this planet revolved around the sun, and the sun was the center of the universe. This was a huge, complete, massive change to what had come before.
Yeah, the so-called heliocentric theory, the theory that the Earth circulates around the Earth, first propounded by Copernicus, but associated forever really with Galileo, depended upon the invention of the telescope. And the telescope, without being technologically determinist about this, as a factor of sea navigation, a need for better instruments in order to navigate around the world. So it's very much associated with the expansion of the European domain on the world, European ideas about things. But I think that you were right there in emphasising the assault on Aristotle. The fall of the Roman Empire had been an absolutely cataclysmic event in the history of Europe. For 1,000 years almost, economic development came to an end and actually went backwards. Intellectual development was very, very stale. And the Bible, which of course is a book which contains much wisdom, much poetry, was regarded, I think almost nobody would say, even believers would not now say, it was regarded as a kind of treasure house of revealed empirical evidence about the age of the Earth, about the location of planets, about natural phenomena of various sorts. And then alongside that, a few scraps of Aristotle, which had survived the inundation of the barbarian invasions and the closure of the Greek schools of philosophy. Much of that knowledge actually preserved in the Arab world, and then transmitted through back into Europe through Spain, through the Muslim civilization in Spain, and then through Venice and the Italian city-states trading with the Arab world. These few fragments had become a sort of dogma, and here we are sitting in the university now, one of the 200 universities or something in the British Isles alone. There's like 3 universities in the whole of medieval Europe, and all they did was memorize these slightly incoherent fragments of Aristotle and attempted to reconcile them with the Bible to make sure they didn't contradict the Bible at any point, because that was heresy, would have been a sort of criminal offence punishable by death. So intellectual life had stagnated into a dogma. And the whole process, I think, is what we think of as the recovery of European civilization to now, in some ways, has been an assault on Aristotle, an assault on Aristotle's physics, on his politics, on his metaphysics, by discovering that they are not compatible with actual scientifically verifiable empirical evidence. And the first major assault on that was simply Galileo's observations of the surface of the moon. According to Aristotle, the dogmatic version of Aristotle, the moon and planets like that existed in an ethereal zone which did not obey the ordinary laws of gravity and so forth that were observable on Earth, and that they were utterly perfect objects, that they were perfect spheres embodying sort of Platonic perfect forms. But when he actually observed it, he could see that there were mountains, that there were irregularities, that there were fissures on the surface of the moon. And so straight away there was a major contradiction in Aristotle's system. And because it was a dogma, the problem with a dogma is everything must be perfect. It must be infallible. Unlike, as you were saying, Brian, the modern method of science, which is basically a method of doubt, that scientists go around having theories about the moon or whatever, and they're constantly trying to prove them wrong. They're trying to prove themselves wrong. And it's now believed that it's actually seeking to falsify theories, that's in the way in which progress is made. With these 2 books, the Bible and what remained of Aristotle, the whole purpose of the universities was to bolster these books and to iron out any contradictions. So the doubt on Aristotle starts on this, in some ways, peripheral point about whether or not there could be irregular shapes on the moon, and then proceeds inwards to undermine his theories of hydraulics, his theories of motion, his biology, and ultimately his political theories is what we care about. Political theory of, for example, the doctrine of natural slavery that Aristotle taught, and therefore it was believed on almost a biblical basis that there are some people who are naturally slaves. And it would have been thought as mad to think of that as being untrue, all people being equal. So the monumental political changes that we see in the couple of centuries after Galileo, the doctrine of human rights, the idle are in fact equal and not natural slaves, that too is an emergence from under the shadow of the dogmatic form of Aristotle.
I think that's absolutely right. I mean, if we go back and look at each of these people chronologically, first of all, Copernicus, his view was essentially, as I explained, that the Earth was just simply another planet that was going around the sun, which, as you said, went against what Aristotle saw the celestial bodies as static, as unchanging, as perfect.
By existing crystal spheres that were interlocked. Yeah.
Exactly, and Copernicus introduced sort of an imperfection to Aristotelian view. Young hero was sort of who did the real intellectually challenging aspect of proving what Copernicus had sort of thought, because Copernicus came up with the idea, he wrote about it, but he really didn't get busy with working very, very hard to empirically prove and establish beyond reasonable doubt that the Earth did go around the Sun. And what Kepler did day after day for decades was to observe the movements of the planets and diligently write this stuff down. And so that he had just massive amount of data in which he could check to make sure that the theories were absolutely right. And this is consistent with a contemporary Francis Bacon, who sort of credited with coming up with a scientific method of experiment, of gathering data and checking it empirically. And so these were gnawing away at the certainties that were at the centre of the society at the time. Galileo is a man that everybody remembers. He's the one that gets the credit for all of this. And this is largely because of his use of this fantastic new technology, the telescope. The telescope was people make the mistake of thinking he came up with the telescope. He didn't. This was discovered by in Holland, and that he got a hold of it and perfected it. And what he
originally, these things were the old sea captain's kind of spyglass that they needed to navigate. So it's very interesting that the money-grubbing Dutch at this time, very commercial people, need all this technology in order to navigate around the world, so they can buy and sell stuff, and that gives us this technology, which then finds a use in the scientific realm. I've actually seen Galileo's telescope, and it's a marvellous object, and it's very small. It is like your traditional idea of a sea captain sort of thing, but it's covered in all these kind of gargoyles and sort of scrolly magical bits. It's a really amazing object but today it would be akin to building the Hadron Collider or something. I mean, more than that though, because even the Hadron Collider gives us more knowledge about our existing theories, basically more sophistication. This instrument simply opened up a new world that was unimaginable. And eventually, of course, we had the microscope, not really until the 19th century, which in the same way reveals the microscopic world of organisms and so on. So data, new types of data, new extensions to the field of perception comes in and fundamentally undermines dogma.
Exactly. I mean, and to return to your point about the assault on Aristotle, I mean, Galileo wrote about this, time and again, and when he was trying to prove to these people that the solar system did exist in the way that he had suggested, he said to them, "Look in the telescope." And these churchmen wouldn't. They refused to look in the telescope. They said that it was trickery, some sort of magic.
The devil or the demons and so on.
Exactly, but and what Galileo would have said was that Aristotle would have looked.
Yes.
And
I think that's right. I mean, this is not a personal attack on Aristotle. I mean, his theories on biology, for example, are still useful. I mean, it's to Aristotle we owe the fundamental categories of biology, species and subspecies and so forth. And Aristotle's logic survived even until about the year 1900, until into the 20th century. Even Galileo and even Newton is still using Aristotle's logical system. Basically, Francis Bacon with the new organon had adapted it a bit, but essentially the logical system, the way of organising knowledge, was still used by all these scientific people right up until Russell and Frege decided that Aristotle's logic was, and that's really the final straw for Aristotle. He then becomes essentially a figure in the history of ideas, with no really valid current ideas. But that doesn't happen until the 20th century.
But the church put up a very, very big fight against this. It didn't go easily. It tried to silence Galileo, and this was a sort of a dark moment for the church. And it is something. It seems ridiculous now, but the Vatican recently apologised to Galileo. He's beyond sort of caring now, but apologised because the Inquisition did sort of intimidate Galileo into silence, and this did have an effect on some of the intellectuals across Europe. They did resist, they pull back from ideas and thoughts that sort of flew in the face of religious dogma at the time. In the brief few minutes that we have left, it's worth mentioning Newton, of course, because for a lot of people they see Newton as the beginning of the Enlightenment. He is somebody who. The phrase that we use, or the image that we use when we do the lecture, is the idea of the Clockwork Universe. And Newton, in his later years, said that even of all the things that he discovered and all his achievements, he saw himself as a child standing on the shore, just playing in the shallows while the great sea lay beyond. But the key thing was that he was in the sea. He was trying to understand the universe, and this is sort of the great achievement of Newton, because even though a lot of his discoveries, his ideas,
the Einstein, with much better telescopes 200 years later, was able to spot that the orbit of Mercury doesn't conform to Newton's laws of motion. And that's what set him on the path of general relativity, which is a thoroughgoing debunking of Newton. But Newton was absolutely correct. His laws were absolutely for the data that was available in his day. He hadn't made an error in his mathematics or his logic or his calculus. It was only that his data was poisoned because the telescope wasn't accurate enough.
I mean, for me, to encapsulate the period that we're talking about, Copernicus dislodged humanity from the sacred to this point that it had enjoyed, which was the centre of the universe, the centre of everything, chosen by God, placed in this situation because of their preeminence. This Copernicus, Galileo, Kepler dislodged us, but the achievement of Newton is that he suggested that the universe was now knowable to us mortal, imperfect creatures, that what had been just the dominion of God, beyond our understanding, like children, but now Newton was saying that this universe is incredibly complicated, but given time and given the right sort of method, the scientific method, it now became knowable. It became...
all you needed was better clocks, better measurement of time, more powerful, but the universe is out there and it is consistent. And this is his point, surely, that we're using the word universe, universal, that the law of gravity operates in the universe in the same way. And I think moving on from Newton now into the realm of politics, and we have people like John Locke and the whole idea of universal human rights. There's no more people who are possessed by devils or infidels or everything like that. Humans are essentially the same, and they obey the same kind of mechanical laws of understanding the world, and morally and ethically. The institutions that ought to go, legal system, political system, ought to also
a contractual basis, things that we agree on, things that we think are important in a society, and somebody like Locke tried to establish as sort of a fundamental bedrock of what we can expect as human beings, and that we are all, as you say, universal, that we all should expect a very minimum of rights, and natural rights as he described them. But I think at this point we've sort of covered a great deal of territory. So just to hand over to Karen.
Thank you very much. I'm Karen Pennell. I've been here with Brian Thornton and Chris Horry. talking about the history and context of journalism. Thank you for listening, and look on the website for more podcasts for this course.